signal level back, will bring it down. So I doubt you will see any peaking action of the filter because of this ALC loop here. So to get away with this problem, I decided to cut this line at this point here and insert a relay at this point, okay? And I'm going to control this relay again from a single switch, a single dual pole, dual throat switch in the RF head. And here's our relay. And notice that I have a 6 volt AC relay about 168 milliamps. And there is a reason for the AC relay, because here at pin 3 of this connector, which is, I'm not going to use this connector, but we have the cable already to near this area of the connector. So pin 3 is directly connected to the output transformer here, the filament output transformer, which is 3.6 volts AC. And the vacuum tube, which is connected also at this point in the vacuum tube inside the 190A remote head, draws about 150 milliamps at 6.3 volts AC. So I figured out that way that if I put an AC relay at this point that draws 168 milliamps, it will be essentially almost equal like having the remote head of the A unit present there. Okay, so I'm not going to load the power supply too much. So returning back to the circuit, we're using this the 3 pin here, which is the input, the 6.3 volts AC input, and we're using this this AC voltage here to enable this relay and switch it off. Okay, when we enable this relay, we have we are in the vacuum tube voltmeter position, and we switch off the relay here. So we switch off, we break this line, and this line actually breaks this line here. So what we have done with this little modification is actually we have disabled, sorry, the ALC action if we switch to the vacuum tube voltmeter. So we can only control now our VFO with this potentiometer, the output amplitude. Okay, there's no correction action here. So now we can use our generator output, which will be set only from the output amplitude potentiometer, and we can use actually this output to feed the signal back to our filter or any other device that we need to characterize to peak, and then bring back our signal into the vacuum tube voltmeter RF in, and then to the detector, and then back to the vacuum tube voltmeter without affecting the ALC here due to the relay action. So now we can actually pick our filters without any problem. So that's the basic idea. And notice that, as I said before, I have no attenuation networks here or impedance defining resistors here or other networks. And the reason is that I wanted to be able to define this impedance based on the circuit that I want to measure. So, for example, if there is a filter that is of high impedance, I don't need to connect any 50 ohm resistors at the input source or the destination resistors, the termination. Okay, but if for example I must characterize a 50 ohm amplifier input and output impedance, then I may have to load this port here on with 50 ohm, and then load the output port with 50 ohm and use a 50 ohm coaxial cable to connect the amplifier on both ports. So and if I want, for example, 1 mega ohm to connect this to my oscilloscope, I can remove the 50 ohm resistor from the source or the destinations, let's say, and replace it with a 1 mega ohm. So I have more versatility here if I don't include any shunt resistors to define the source and the termination resistance at these 2 points. Now, how about the attenuator? Well, I wanted to be able to at least use the scale of the generator, all of the scales, the top, the middle, and the bottom scale of this generator, to be able to actually do the measurements. And the manual describes that the attenuator setting must match these settings, these 3 settings here. So for 10 volts maximum signal, you have to set the attenuator to 10 volts, and for 5 volts to 5 volts, and for 2.5 volts to 2.5. As I said, the vacuum tube voltmeter only reads from 0 to 10 volts peak to peak scale. But when you set your attenuator, you just read the scales below, because the attenuator is after the sampling point of the diodes. Okay. All right. So I will try to build this circuit here and measure it and see how well it works, and calibrate this unit and see how useful it is at the end. Final thing I should mention before this is that in order to be able to read the middle scale, you need a 6 dBs attenuator, 6 decibels attenuator, and in order to be able to read the bottom scale, you need the 12 dBs of attenuator. I'm going to use inline attenuators for this. I could use a switched network attenuators, but the problem with these attenuators is that they are mostly 50 ohm input and output impedance. So I can't have a permanently connected 50 ohm switched attenuator at the output of the generator. I think it's much better depending on the impedance, the output impedance of the generator and the input impedance of the vacuum tube voltmeter. I think it's better to use attenuators for that impedance. For example, if I want 50 ohm, I insert a 6 or 12 dBs 50 ohm input and output impedance attenuator. But if I want a 1 mega ohm, then I insert a 1 mega ohm input and output impedance attenuator. So that's why I decided not to include in the original circuit any attenuators and include them outside of this circuit, depending on the setup I want to do every time. Okay, another thing that I wanted to mention is that there is another option if one wants to use a purely vacuum tube head in the circuit, and this is the type 190A detector directly from the Tektronix datasheet. And if we read on 7 page of the datasheet here, page 7 of the datasheet, it says that the type 180 attenuator, which is the vacuum tube head, can be used directly without modification with all types of instruments, including the 190B, which is my version of the instrument. So we can directly use this detector, and I have already drawn a circuit for it. Here it is. This is directly drawn from the Tektronix datasheet, and this is the same as my previous diode-based circuit, semiconductor-based circuit, but now it uses a dual vacuum tube diode for the purpose. And This time I have used the 6AL5 tube, which seems to be okay for the purpose. It's an RF vacuum tube diode, 7 pins.